Hello and welcome to this third video on coordinate geometry, and in this video we're going to explore tangents to circles in a little bit more detail. So we have here the equation of a circle. So you should be familiar with this from the last video, and we're told to find the tangent to this circle at the point -1, 6. So presumably the point -1, 6 lies on this circle. Might be worth us just checking that to make sure that is the case. So if I substitute in -1 for x, and if I substitute in 6 for y, does this give me 100? So -1, -5 is -6. And 6 plus 2 is 8, so that gives me 8 squared, so that gives me 36 plus 64 equals 100. So yeah, it definitely lies with on this circle. So let's do a little sketch. So the centre of this circle is the point 5, -2, and I know that because the equation of a circle is x minus a squared add y minus b squared equals r squared, where ab is the centre. And I can also find that the radius of this is 10 units. So let's attempt to draw a circle. Could have been worse, but not great, but never mind. Okay, so where is the point -1, 6? So it's the x coordinate is to the left of this one and the y coordinate is above, so it's going to be up here somewhere maybe. Okay, so that's supposed to be straight. So we're looking for the equation of a tangent that's up here somewhere. So what we can tell about this for sure is it's going to have a positive gradient. And we can tell that just from our sketch. Even though it's a pretty rubbish sketch, it's good enough for us to tell that. So we also know that a tangent is a straight line. And we know that the general equation of a straight line is y equals mx plus c. And in order to find this, I need the gradient and the y-intercept. Now I have a pair of coordinates. I have -1, 6. So I have a value of y and x. So if I can find a value of either m or c, then I'm okay. Now we're not going to be able to find c in this case, but we are going to be able to find m. And that is because one of the things we should know about a tangent, or a tangent to a circle specifically, is it's perpendicular to the radius of the circle. So that's really helpful, because if I can find the gradient of the radius, I can then use that to find the gradient of the tangent. So how am I going to find the gradient of the radius? Well, I can use my diagram and use a diagrammatic approach. So I'm just going to drop a vertical and then extend a horizontal, make a right angle. And then the gradient is the change in y over the change in x. So if I look at the y coordinates, it's gone from -2 up to 6, so it's increased by 8. Looking across, it's gone from -1 to 5, so it's increased by 6. I can also see that the gradient is negative, so I'm going to write this grade of tangent, of radius even, is going to be equal to -8 over 6, which I can simplify to -4 over 3. I could also, if I'd wanted to, have used the formula m equals y2 minus y1 over x2 minus x1. Okay, but doesn't really matter too much. I already had a diagram, so I might as well use the diagram in this case. Alright, so I've got the gradient of the radius. So the gradient of the tangent then, well, if it's forming a right angle and they're perpendicular, hopefully you know from work you may have studied in regular maths that the gradients of perpendicular lines are the negative reciprocal of one another. Another way of thinking of it is they have a product of -1. I prefer thinking of it as a negative reciprocal, because in practice it makes it a bit easier to deal with. So what's going to happen here? Well, the reciprocal of 4 over 3 is 3 over 4. And because the radius was negative, the tangent is going to become positive. So I've got my gradient of my tangent is 3/4. And now I've got the information I need to substitute into y equals mx plus c. So the value of y is 6, value of m is 3/4, and the value of x is -1, and then plus c. So 6 equals -3/4 plus c. Add 3/4 to both sides. So that's 6 3/4 equals c. I quite like improper fractions rather than mixed numbers, so I might just convert that, which is going to give me 27/4. And then the equation of my final line then is y equals 3/4 x add 27/4. And that's the equation of my tangent. So here's a similar question that you can have a go at. You don't have to use a diagram, but you might find it useful to do one. And then here is the answer. And then here are some questions for you to have a go at. So set A is just what we looked at a moment ago. You can see there's a couple of questions with sets towards the end for a little bit of extra challenge. And then set B, you've got a slightly more awkward question to deal with. And be aware there it says find the coordinates of the point of intersection of the tangents, plural, to the circle at x equals 4. Okay, and I'll leave it to you to see if you can figure out how to deal with that information. And then here are the answers.